Hello, this is the luckiest maths teacher in the world. Last time we learned 3 index laws. Today we're going to learn more. So the 3 index laws on your screen are the 3 that we learned last lesson. So now we're going to learn 3 more. So first off, we're going to look at raising fractions to a power. So let's say I have something like this, 2 over 3 to the power of 4. Okay, so if I write this in expanded form, I know that 2 over 3 to the power of 4 is just 2 over 3 times by itself 4 times. Now, because of the way that we multiply fractions, I just multiply all the tops, so the number that goes on the top is 2 times 2 times 2 times 2, but I know that that is just 2 to the power of 4. And on the bottom is 3 times 3 times 3 times 3, which is 3 to the power of 4. Okay, so this would work exactly the same way as if I was using, say, letters instead. So I'm going to raise this fraction, x squared over y, to the power of 2. So I'm sort of expanding the brackets, I'm getting rid of the brackets. So this would be x squared over y. Now squared just means times by itself. Okay. So x squared times x squared, you know, is x to the power of 4. Y times y is y squared. Okay, now x to the power of 4 is the same as x squared squared. That's using the third index law in black that we learned last lesson. So basically what we can see from these two examples is that if I have a fraction, a over b, and I raise it to some power, that is the same as raising the top number to that power, raising the bottom number to that power, and just leaving it as a fraction. Okay, very simple. Now I'm going to go through another index law, so copy this example down if you want to keep it. So let's say I've got something like this, 2 times 3 to the power of 4. Okay, so again, we're using the definition of power. Raising to a power, we just times by itself 4 times. So this would be 2 times 3, so that's 1, 2, 3, and 4. Okay, but of course, as you all know, the order in which we multiply things doesn't matter. I can get rid of all of these brackets as well. So what I'm left with is there were 4 2's and 4 3's. So this is expanded form. To write it in index form, I've got 4 2's, so 2 multiplied by itself 4 times 3 multiplied by itself 4 times. Okay, this would work exactly the same way as if I had, say, some letters. So ab squared means a times b times a times b. And again, order of multiplication doesn't matter, so I can write it like this. So what you can see in both these examples is if I have a few numbers multiplied together in brackets, and I raise that to a power, I just raise each of the things in the bracket to that power. So in other words, my fifth index law, if I have a times b in a bracket, and I raise it to some power m, that's exactly the same as raising the first thing to the power of m and multiplying by the second thing raised to that power. Okay, again, I'm going to clear this and write the next index law, so please copy it down if you like. Now the last one that I'm going through today is a bit different. It's called the zero power. So what happens when you raise something to the power of 0? So let's think about this. What would be 3 to the power of 0? Now, intuitively, you probably think, okay, I'm raising 3 to no power. I'm not multiplying anything, so it would equal 0. But the way we define 3 to the power of 0, or indeed anything to the power of 0, is by using the other index laws, because we want this to be consistent with the 5 laws that I've just spoken to you about. So, let's consider something like 3 to the power of 4 divided by 3 to the power of 4. Now, if we use the index law here, number 2, we are dividing bases, so we subtract the indices. 4 minus 4 is just 0. So 3 to the power of 4 divided by 3 to the power of 4 equals 3 to the power of 0. That's just an index law. But 3 to the power of 4 is also the same as 81. So 3 to the power of 4 divide 3 to the power of 4 is 81. Now anything divided by itself is 1. So 81 divided by 81 is 1. But these things have to match up. Otherwise it wouldn't make sense. If 3 to the power of 4 divide 3 to the power of 4 equals 0, but it also, equals 3 to the power of 0, but that also equals 1, then these two things must be equal. If A equals B and B equals C, then A equals C. That's how numbers work. So, anything raised to the power of 0 is 1. There is, however, one exception to this. So I said before that anything divided by itself is 1. Well, I'm sorry, guys, I actually lied a little bit. Anything divided by itself is 1 unless that thing divided by itself is 0. So, for example, 0 to the power of 4 divides 0 to the power of 4 is 0 over 0. Now, you can't divide by 0. You can't divide anything by 0. Because you're saying how many times 0 go into 0. If you do, say, 4 divided by 0, you're saying how many times 0 go into 4. It doesn't make sense. So this law, anything raised to the power of 0 is 1. This works when the thing raised to a power is not 0. So I write it like this. X to the power of 0, x can be any number, equals 1 if and only if x does not equal 0. Okay? So I'm just going to go through a few very quick examples on the next slide. So I'm just going to quickly go through each of these examples. So the first example, 2x to the power of 0, so you have to figure out which index law you're using. Obviously, since there's a 0 power, we're going to use that index law. Now, it's probably tempting here to say that the answer is 1, but note that this is the same as 2 times x to the power of 0. So only x is being raised to the power of 0. So this part is 1, so I can rub that out and write 1 instead. X to the power of 0 is 1. So the answer to 2x to the power of 0 is 2 times 1, which is 2. Note that this is actually different than if I went like this, 2x to the power of 0. In this case, I'm raising everything to the power of 0. So assuming that x is not 0, this would be equal to 1. Please note the difference between this and this, the difference being order of operations. Alright, second example. So I'm using the index law that I went through first today, index law number 4, because I have a fraction and I'm raising it to a power. Now I'm also using the raise a power to a power index law here. So what I do is I raise the top number to the power of 2, so y cubed, I square that, and I do the same to the bottom, raise that to the power of 2. Remember, I multiply the two indices together when I raise a power to a power. So this will be y to the power of 3 times 2, which is 6, divided by x to the power of 2 times 2, which is 4. That's my answer. I'm done. Last one. So this is the second index law I went through today, index law 5. So in the brackets, I'm multiplying a few things together, and I'm raising that product to the power of 5. So, as I said, the way we do that is we take the first thing in the brackets, raised to the power, times by the second thing in the brackets, raised to a power. Again, I'm going to simplify this by using the index law we went through last lesson, raising a power to a power. A to the power of 2 to the power of 5. Remember, we multiply these two together. That becomes a to the power of 10 times b to the power of 5. And I'm done. Hope you've enjoyed the video. This has been the luckiest maths teacher in the world. Have a great day.